Okay, this is a virtual meeting put on by Allen County Soil and Water Conservation District's Coffee and Urban Soils today. So welcome everyone. We're recording this meeting and request that everyone keep their mic on mute unless asking questions or talking. We will be monitoring the chat function and welcome visitors to use the chat area. I'm Mike Whirling, a technical specialist agronomist with the SWCD and a regenerative farmer on my 175-year farm in near Decatur, Indiana. Today we welcome James Wolff, the agriculture and natural resources educator for Allen County, Indiana. He's going to talk to us about urban soils. James, let's just start right in with you. Tell us about yourself.
All right. So I'm James Wolff. I'm the agriculture and natural resources educator here with Purdue Extension. Been here about 7, almost 8 years now, working with different aspects, and soil seems to be the one thing that I find myself working with pretty frequently. So today we are going to talk about urban soils, because urban soils are, I mean, the premise is the same as regular soils. They're all about the same, but they just appear so much different than the soils that we're used to working with, that we normally find in very undisturbed areas. So we're going to kind of go through this, and if you got questions, feel free to pop them in the chat, or we'll kind of get to them at the end. Purdue Extension is a equal opportunity, equal access institution. Here is our information about that, since we are funded through the USDA. We also have this in Spanish, if that is your language of preference. So just a little outline today. We're going to talk about urban soils, which is this nice little picture here on the right, what we're seeing. We're going to talk about the soil conditions of urban soils. We're going to talk about a little bit about the site assessment in that growing process, a little bit about soil sampling, just kind of scratching the surface there, and then kind of finishing up with, okay, you've got urban soils, what do you do now? And again, this is kind of all really scratching the surface here at a quick hour, but you'll get a good understanding of what makes urban soils unique and how to deal with those challenges. So in our first slide here, this is what we find if we go out to like a cornfield in Indiana. This is most likely what you're going to see. We're going to have this nice layer of organic matter right there on the top, that dark kind of band right at the surface, right below the plants. You're going to see a topsoil layer, that A horizon as we call it, but that topsoil, that rich soil that's usually got most of the nutrients in it that we're really looking for in plant growth. Then we get that subsoil, which is just below it. It's going to be your base layer. It's usually going to be a little bit more clay, but we do have some sandy and some outwash type soils in Indiana. And then usually way down here, we're going to find some bedrock, that parent material that we're sourcing from. In southern Indiana, the bedrock tends to be a little more noticeable. In northern Indiana, it's a little deeper in there, but this is a really nice soil profile. You're usually going to be, maybe about 30 inches down into that subsoil. You get nice layers, different color bands, showing all that. Really nice. That is not what we find in our urban settings. So when we look at the physical conditions of our urban soils, we're usually looking at things like this. And we're going to show some variations to this as we click through here. But we really have this unknown altered soil profile. We can really only see what's on the surface. We don't know what's happening below the surface. until we start digging down and see what's going on here. Usually we're not going to find distinguishable horizons, and if we do, they're probably not in the order that we want them in. We usually are going to find some subsoil fill above topsoil because, well, people fill the holes that are left behind pretty cheaply, and subsoil is more expensive or less expensive than topsoil. So subsoil tends to be the thing that gets used to fill in. You're going to have layers of rock, and a lot of times that rock is basically foundations. They break the foundation up or they leave the foundation, and you just got this really nice layer of rock in there. There can be pavement. Sometimes you'll actually find that pavement is kind of layered in the soil because it was paved, it's been left to sit for a long time, dirt built up because nobody's cleaned it, and suddenly you've got this little layer of pavement somewhere under this layer of soil. And then just unknown debris of all kinds. You're going to find a lot of buried stuff, especially if there was a house that used to sit on a vacant property that was probably just used to fill in the hole from tearing down the house. But there's also other things, all the way to having, old oil heating tanks just kind of left within the soil layer. So when we talk about buried horizons or subsoil fill, this is what we're talking about. So we've got this darker layer here, which was what we would typically see as a topsoil, but above it is this lighter layer, which is more of a subsoil type layer. It appears kind of that lighter color, clay color. That's usually what a subsoil looks like. Very, very rarely are they really dark in nature. They're usually a really light color. So this is what case, again, you can see a nice little clearly defined line. That usually means that that's been filled in on top. And the challenge is going to create challenges with our chemistry when we talk about this physical condition being different. The next thing is just debris in our soil. So here's a nice little plastic bag. I didn't take the picture. We've got this from our stock photos, but with an extension, and I'm just hoping that maybe that's not a body, but on the lighter side, you're still going to find trash buried. You're going to find just about anything in there, just plastic bags of whatever. But you can also see, look at all this rock that is just down in there. You might see like maybe a little metal bar. You kind of got some other stuff, up in here, and that's not stuff that you would normally see in your soil. We don't have really rocky soil unless you're close to a river in Indiana where you'll get some outwash. Most of our soils are a little less rocky than this, but clearly there's a lot of debris in that, and that's going to be hard for you to work around if you're trying to dig in the soil and do a lot of stuff. But B, it's also really hard for plants to work around. They come across these barriers in there, and it just becomes a real challenge for them to grow well. The last kind of physical condition that I really like to point out as being something that's drastically different. We do see compaction in our farm fields, usually because our farm equipment's big, it's running over this ground a lot. But it's also kind of less, maybe it's less extreme than you really notice in urban settings, because it's just like constant compaction and nobody's trying to break it up any. So here's an example of that compaction. What happens is people have used this as a walking path, and just that foot traffic has really kind of compacted that soil, pressed it all together. It makes it into more of a brick, a concrete, and it doesn't allow water to infiltrate. It gets really hard, it gets really dry. You'll notice like there's this puddle formed back there. That puddle's there because that water can't go anywhere else. So if we've got soils that are loose and more arable, that water is going to either it's going to percolate better, it's not going to build up. You'll see more plant growth, because two things plants don't like is being walked on consistently, but the roots also just can't really break through this layer of almost concrete from that compaction. So again, that's why some places use the mentality of, well, let people figure out where they want to walk, and then we'll build the sidewalk, because now they've made it nice and compact for us. But it's also, again, another reason why in urban settings where we've been driving a lot, where we've been walking a lot, you don't see anything growing there. And we've got to fix that in order to be able to get nice production from that soil. So the next thing we look at, the chemical side of soil. The chemistry of our urban soils is a lot different, and part of that is because the physical condition is different, but also part of that is just the environmental factors of being in the city where there's more exposure to heavy metals. You've got your exposure to asbestos, especially if we were just filling in where we tore down buildings with the building itself. There was a lot of asbestos used in the past. There's a lot of pesticide use that's more so detrimental than maybe some of our farm pesticides, and then just all sorts of other contaminants that are just picked up through the process of being around an urban area, the building, the construction, the cars, the traffic, the people, the trash, just everything. It's just so much more, so much higher levels than you would find in a more natural area. So again, we kind of have some examples here of potential soil contaminants and where their potential source is. Not a very exhaustive list, but definitely a list to give some context to in your situation. And then here again, another slide, looking at a general source, previous uses on the site, and then the specific contaminants that could be an issue. So we talk about burning waste, you get some chemicals there, even treated lumber, which is another issue that we look into when we're even considering raised beds or different structures within our garden. You could be getting some contamination from treated lumber. Even being next to high traffic areas can lead to some lead and zinc contamination. And then the biggest thing we find is lead usually, and that's very often, especially with a vacant lot, your lead comes from paint, usually on the drip line of a house, along the sides of a house, usually not in the footprint of the house unless that's where the house was buried. We usually see it around the edges where it was able to chip off the sides, erode off the sides, and be deposited in the soil there. So again, just kind of going over some soil contamination sources. A lot of times we think, lead cleanup areas from, a lead facility. You've got some sort of a industrial complex that then led to contamination in the soil. We think of places like, Gary, Indiana, the steel mills, and, whatever they're putting in the water, whatever they're putting in the air, these big smokestacks. But that's not always the source of our contamination. A dry cleaning facility, they use a lot of chemicals in the process. How did they dispose of those chemicals? Are those chemicals still there? Are they just sitting out in rusting drums out back? You got tires. Sometimes, some of these lots, the debris, the garbage just builds up. So tires, rusting metal, different things just laying out there. And again, like I talked before, a lot of houses used to have heating oil. The barrels used to just be buried in the ground, and often those are just left. But all of the oil and the metal associated with that is still there. But there's also a lot of other things that are just buried in the ground that we don't know about that contribute to that factor. So then, like, those are the bad side of the chemicals. The next side of the chemical conditions is just your nutrient levels, and that's the nutrients that the plants need. And the biggest thing is with nutrients, we often see low fertility because of the soil conditions. When we talk about that subsoil being put on top, that subsoil is not highly nutritious. You're going to find more nutrients in a topsoil, especially closer to the surface. When you put that subsoil on top, there's not a whole lot of nutrient content there. There's not very much organic matter in our urban settings most of the time. So there's not that aspect to it. So our pH is also going to be low, or it's going to be high. We see it kind of both ranges. An ideal range is 6 to 7-ish, kind of there. Most of the time, I don't know that I've seen, but maybe 1 or 2 soil tests come back to our office that have a pH below 7. In a lot of cases, we're averaging 7.5. I've seen them as high as 8.4 for a pH, and that is getting really basic and not a good range for nutrient uptake. So looking at those nutrient levels is going to be very important. And then again, we want to make sure that we've got the right amount of nutrients, because if we've got too little nutrients, our plants struggle to grow. Weeds are able to outcompete. Soil that's got the right amount of nutrients, plants are going to outcompete your weeds. You're going to see reduced yield, when they're weak, they're sick, they're more susceptible to disease and pests. So you just got a lot of growth issues if there's too little. But also on the other side, if we've got too much nutrient, we also see a lot of runoff. Leaching can cause pollution. We're worried about our watersheds here. There's a lot of hardscape in an urban area, so runoff is really important in making sure that we're not applying too much fertilizer. It stays where we want. Also, if we're fertilizing too much, our weeds can kind of take control. We can cause plant damage. And quite honestly, if your nutrients not going into the plant, it's not going where you want it, you're kind of just spending money. You're just throwing money at the ground for it to run off. And that's not wise either. So making sure you've got the right amount of nutrient is going to be most economical and most environmentally friendly as well. And again, just kind of quick overview, the chemical nutrients we're mostly worried about are macronutrients, the ones in most need. N, P, and K are what you would get in a soil test. Carbon, hydrogen, oxygen, those are associated with the water and the organic matter content. And then we've also got our pH related ones, which are the sulfur, the calcium, and the magnesium levels. And then that last, when we talk about the condition of soils, we're also looking at the biological conditions of the soil. Or our urban soils lack a lot of biology. They lack that organic matter. They've been so sterile over the years from lack of, when you put pavement on something, it's not going to have a whole lot of plant matter or living matter underneath that pavement. So we really have to work to bring that back. And there's different ways to work on that, but cover crops, having green material on the soil all the time helps work through that. Eliminating that compaction helps, other small organisms come, and those small things bring larger organisms. So looking at that biology that really adds that organic quality, adds some extra life to the soil, is going to be beneficial for urban production as well. So I also like to cover a little bit of the site assessment stuff, because that helps you figure out what you've got, what you're dealing with in your soil. Because again, it's really easy to walk out there and see what's on the surface, but it's really hard to see what's below that surface of the soil. So there's some ways that we can work and figure that out. One of those is to basically know what problems may be present, and we do that through finding the history of the site. I really like to go to, in Allen County here, go to the historical aerial photos at the GIS map that Allen County has. That gives us really great aerial photos. They're kind of blurry as you go back to like 1935. They get a little blurry, but from the 80s on, they're pretty clear. But it kind of gives you an idea that there might have been a building there. There may be some concern. You can check property records on a site, even talking to the neighbors. Just because you see a building there, what was in that building? Some of those neighbors may have been in that neighborhood for years and knew that that was a dry cleaner for a while, or maybe it was just a grocery store, or maybe it was, maybe it was a garden before. So they can help you tell what was going on in the site. And then also the next thing on a site assessment is doing a soil sample, finding out what your nutrient quality is, what your heavy metal capacity is in that soil. That then is the next step in that site assessment property or process. Heavy metals, I'm not an expert on heavy metal testing, but you can wear, or you can sample soil. If you wear, I would recommend wearing proper protection, because you don't know what's in the soil at the point you're testing, but there could be potential. You could also hire a professional, and then also determine what you want to test for, because it's not like a nutrient test where you just send it in and they give you all the nutrients back. You need to let the lab know what specifically to test for. Lead, arsenic, and chromium tend to be the most common. Zinc, cadmium, and mercury are also fairly common as well. Usually there's going to be a cost per chemical you're sampling for. And also just make sure that you find a licensed lab that does testing. I do not believe A&L Labs in Fort Wayne does, but they will outsource it to another company if you would like the heavy metal testing. And make sure that you find out if they've got special collection procedures, find out their pricing to help you make your decision on how you're going to handle that. The next one is basically determine where you're going to sample, what is the most likely to sample, because these can be expensive tests. So you want to make sure you're sampling the right areas and do it properly, following your lab procedures. But if this was on the left-hand side was the lot we wanted to use to grow, looking back on historical photos, we can see there used to be at least one house there. It looks like there was probably another one here that had been torn down. If we look at that final picture, what is determined is there's a busy street out here. So we kind of want to sample that area. We want to sample the drip lines, those drip line areas of where the houses used to be, simply because that's going to be your highest potential for lead contamination. And then another area that's potential for testing is just that middle where that house used to sit, that footprint, simply because maybe it was buried there, maybe it wasn't, but there could be some other factors going on in that process there. The lowest areas would probably be these grassy areas, maybe right in here. Maybe this was just a concrete pad as well. So there could actually be some contamination from if cars were sitting there or here. those cars leaking oil or antifreeze or whatever they might be leaking. So that would be kind of the considerations for testing. And I will say, like, going back to this, at Johnny May Farm that we operate here in the city, you can tell kind of based on our heavy metal test that had come back from the city, you can kind of tell where the houses sat on the lot because they divided it into 5 different sections when they did their heavy metal sampling. And the 3 sections that correspond with the highest levels were basically right where the houses, where the lots where the houses were. When we do nutrient sampling, again, it's pretty much very similar to probably what you've heard a dozen times about nutrient sampling. We're looking at that 4 to 8 inches depth, making sure you get 2 cups per sample. 1 sample per acre is what I recommend. And also keep different parts separately. So if you got raised beds and you've got in-ground sections, do 2 samples. If you've got flowers in one area and vegetables in another, do 2 samples. And the same with perennials versus annuals. So if you got like strawberries and asparagus, you might sample those different, or like berries, you might sample those separate from your tomatoes and cucumber area. Just because you're treating them differently, the plants have different nutrient requirements. So it kind of gives you a better idea of what you should be doing in those areas. And also if you use a shovel, we want to make sure that we just get that center section in the sample. So because the nutrients are distributed more at the top, and this is not a very even sample if you're just taking all of this as opposed to, because you're getting more of this top layer, which has more nutrients than this bottom layer. So I always just take off the sides, get about 1 inch or so wide, just like you're doing like with a probe. You stuck a probe in the ground. I get rid of the excess grass in there, and that leaves us with this last sample, which is what actually goes in the bucket for collection. Here's also another little example about different parts. So this is my parents' farm. I keep the front and the back separate because the back sits on the septic system. It's also a different variety of grass. It grows different. This is kind of up on the front on a hill. Different grass, so they're really different situations, and we should treat them differently as we're taking care of them. This again is also just slightly different, and then this is where the old house used to sit, so it's a lot different conditions over here, and that's actually probably subsoil fill. So again, that's why I would treat that separate. So that's talking about kind of keeping things a little separate in those areas. And again, just a quick do and do not. Do allow plenty of time for the lab. You know, sample if you sample in the spring every year. You know, about 1 acre representation, and draw where you took your sample. Don't use a metal bucket because you'll get the galvanized metal will skew the results of your soil test. Don't sample after you've applied fertilizer. Don't undersample, make sure you get a good representation, and try to keep areas separate. So you figured all this out. Now what do you do? How do you handle your soil and make sure you improve it? It's hard to fix soil. It really is. It's not going to be a quick overnight fix. Even with nutrients, it's not a quick overnight fix. But you can work to improve it and work to make it a good environment for plants to grow. And that's going to be dependent on 2 factors, and that's what's wrong with your soil and what are your production goals. So First is to look at what your soil report says. Blindly adding nutrients is not helpful at all. It creates those imbalances with plant growth issues. It creates environmental issues, that runoff we talked about. Just not a good situation. The other thing is organic matter, compost are not silver bullets. Make sure you consider the source. You need to have patience. And figure out what other issues exist within your soil report. Yes, we want to have that organic matter. Yes, compost is good, but what's the nutrient analysis of that compost? How do you know you're applying the right amount of nutrient? The same with organic matter. It's good to have, but if it's not incorporated properly and you add too much, it's still not any more helpful than anything else. So making sure, again, we're applying the correct levels of NP and K. Micronutrients, if you're starting out fresh on a site, you might consider getting a micronutrient test. Generally, I don't test for micronutrients unless I notice a deficiency in the plants. But that's kind of, up to you if you want a full baseline of everything and go from there. Consider your source, organic versus inorganic. You're going to have to add less Miracle-Gro than you do an organic fertilizer like compost, simply because organic fertilizers have a lot less nutrient per pound than inorganic sources. So just making sure you balance that properly. And again, knowing the nutrient levels of your compost, you can go take your compost and get a nutrient analysis done at the lab. Same with manure. So that can be helpful. One second there. Oops. So okay. And then also a soil analysis is not a full picture of the soil health. So it's just like going and getting your cholesterol checked. Great, your cholesterol level. Is that your total health picture? It's not. It's just one aspect of that process. So you got to look at adding tilth to the soil, trying to get that soil broken up so it's not so compact. Use cover crops. Keep living material in the soil year round. Making sure that you're building up a biological factor in your soil. And considering other environmental factors. What else is going on within the space? What's going on around the space that's contributing to what's going on here? And also, again, environmental factors could also be your floodplain. In Allen County, we've got lots of rivers. Some of that stuff sits in floodplains. Some of these great areas to grow sit in floodplains. You're limited. You can't really bring anything into that floodplain, like bringing in compost and bringing in more soil to that site. You've got to basically deal with what's on site in that consideration. So keeping that in mind is important. And then what are your production goals? Are the levels significant? Are there issues that are going to create significant problems? How can you mitigate heavy metals, for instance? There's two ways: it's remediation and non-remediation. So that remediation is going to be basically, according to the EPA, it's removing the soil. It's going in there, excavating, installing geotextiles, or from a biological standpoint, where you're going to go in and take stuff out of the soil, basically, or change that soil chemistry to remove the problem. This can be very expensive. There's also non-remediation, which doesn't mean not doing something. It just basically means that we're going to leave the current uh, environment, let everything exist, but you're going to plant above ground. You're going to do things like installing raised beds, container gardens, green walls, rooftop growing, aquaponics. You're going to use some other growing method than in the soil that's there. You're going to kind of build up from that in some way. So which do you use? It really depends on your levels of contamination. I mean, if you're really severe, you might consider the remediation method. But you're also looking at the cost of doing that. So sites with low levels of contamination, like what we see at Johnny May Farm, we're able to do some non-remediation method with raised beds, reducing risk of exposure, those sorts of things. Also, again, this can be non-remediation can be used in situations where you've got, a hard pan where there's backfill, asphalt, the ground's too full of debris. You can use that to basically grow up on your site. Also in this remediation process, consider a lot of different things. Exposures not just from to heavy metals is not just from the plants taking it up and then eating the plants. In a lot of cases, it's in that dust on the surface of the soil. So anytime you're out there working in it, you're picking that dust up, you're getting it all over your hands, you're getting it in the air, you're breathing it in. So anything you can do to reduce that being spread is great. That's a lot of times through we use grass. I mean, soil is just covered in grass at the farm. The only place that we don't have grass is basically where the vegetables are growing. And that's going to basically help keep all that soil together and reduce a lot of dust in the air. We use grass as our walkways, those sorts of things. So there's a lot of different strategies with raised beds. So the first is basically beds with frames, your standard raised bed. Also just be careful with treated lumber. Cedar is usually the recommended, or using bricks, concrete, but you can form raised beds in a lot of different ways. This is great on a small scale. This is probably the best application, using wood that's rot resistant. Soil and water are heavy, so they're going to cause those materials to shift over time. So making sure that they're supported really well. There's lots of different plans. So just find something that works for you in your situation. And then mulch around the ground or the beds to keep soil contamination covered, using grass. Like the thing you want to avoid is just bare ground. So again, more say the examples there. That's probably not going to be great on a large scale. So if we're talking like huge lots, acre size, we're probably going to want to do something that's more like this, where we use wood chips to create a frame. And that's going to be like the frame of our bed. And then that's going to be our wood chips that we walk on, and establishes a base. You bring in more good soil, hopefully, topsoil, compost mix, maybe that's not subsoil. And you kind of create your desired bed sizes, retaining walls, those sorts of things, to try and basically grow above the soil. So again, you start with a lot like this. You're going to bring in your wood chips and create these bowls out of your wood chips. You then begin to fill it in with your soil, and then you end up with large beds for a larger production scale than just using small raised beds that can be very time consuming. And wood chips mulch quickly. It decomposes, so you probably want to make them deeper than you think. Mulch will kill off most plants, but some things still grow through there, especially our Canada thistle will go through that pretty easily if you're not careful. So keeping some of those things under control. The mulch will act as kind of your sidewalks. It'll also spill off, so keeping things tidy over time is important. One thing we do, it's a harder style to work with, but at Johnny May Farm here, this is a picture there. We use mounded beds that are just mounds of soil. They've got a flat top, so they're about 2, maybe 3 foot wide on top. They've got a 4-foot base. We could have put them closer together, but we wanted accessibility for the community between the rows. And basically we have to have grass or plant material up the sides of these at all times, otherwise they're going to erode. So that's the challenge. Rain's going to wash that soil off and flatten it out pretty quickly if we're not careful. But you also want to make sure that you're planning ahead and size things appropriately, because if you don't size this right, you've got tools that are too wide or too small. You're not moving efficiently through the bed. We're really limited on like using a rototiller within this. So you just got to make sure that you size it appropriately. And then the last thing here is container growing. It allows you to grow in a lot of situations, even right there on the rooftop. We can just grow in containers. Inside, we do a little bit of container growing inside of our hoop house at the farm. We've got these cloth bags, fabric bags, as well as buckets that we grow in. So we're not directly in the soil. You can build containers, basically raised beds out of wood, some different options there. And that is what I've got. So I think I'm to questions now. Hopefully I didn't bore you all and put you back to sleep, and your coffee's keeping you awake. So it looks like there's a question, where would we find a list of potential contaminations, like the slides I have? I believe, I'd have to double check, but that either came from USDA publications or other extension publications. Purdue does not have a whole lot on heavy metals and contamination yet, because there's not a whole lot of concern with that in the realm of corn and soybeans, but we're starting to pick up some of that. So there are some other publications out there that I can try to find for people.
Nicely done, James. Are there areas in town that are in Fort Wayne or the area that might have more contamination than others? There are hot spots, or can you speak to that?
There are some areas that are probably closer to some of the industrial areas. I mean, you think the old GE facility, there may be, areas around there where our soil could be have a little bit more contamination issue, because that was at maybe one point a more industrial area. There's kind of little pockets here and there. Again, I mean, even just a house, like I said, on our site, we have some contamination. So it's less than 200 parts per million of lead. The USDA basically has very limited guidelines, but they say that you can play in the soil until it's at 400 parts per million. So I mean, that gives you a context. We're not very high. I mean, you talk about, in New Jersey, I mean, 800 parts per million is probably what they're seeing regularly, but it's not high. But at the same point, you want to take proper considerations. I mean, we're trying to make sure that we provide healthy, safe produce and do what we can to mitigate everything as best as we can. So that's why we, take these extra precautions. But yeah, there's not a whole lot of guidance out there on some of that. So it's hard to tell. But again, that's a house sat there with a couple cars, and that's what we've got. Even after, these houses have been torn down for a decade, and that's still what we've got. It's going to be there. It's not going anywhere once it's there. So any of your urban sites can have some.
We have a lot of great viewers on here today. You have any questions for James? Let's see what we can do. Ask him. You can unmute yourself and come on. I know it's a whole different thought process than on my farm here. I went to get my roots down. I have my cover crops down 48, 60 inches, 4 and 5 foot down. I can see where if you hit different material, that's going to be a problem there.
Yeah, and like that would be a great goal to have, because your plants like your tomatoes and such are gonna get some roots that go down, and it's hard to grow a carrot if you've got a compacted layer 6 inches in the soil. Your carrot wants to get a little deeper than that. You want to get a nice foot-long carrot sometimes. So yeah, that's where cover crops can come in, because they can get down in there and help break some of that up, and work the soil a little bit. So there's ways that, yes, we want to use some of these practices we use out in our corn and soybean fields to bring in and redevelop these soils. But at the same time, yeah, you don't have to worry about a limiting layer that shallow out in the cornfield most days.
Yeah. Oh, I see we have a question there. I may have missed this, but is there a good cover crop that you suggest for soil amendments development?
I don't know. It really, it gets down into what you really want to look at. Generally, a cover crop, you're really going to, in an urban setting, you're really trying to get organic matter and break up the soil. So finding things that do that combination are going to be the best. Mike can probably talk a little bit better about cover crops and what might be better for doing that nutrient development, but it's generally going to be a mix. If you want nitrogen, things like clover are pretty common. If you want something that's going to break up the soil, radishes can help, break up that soil a little bit. But those are all gonna, clover, not really, but the radish will winter kill, which is nice. You don't have to go out there and terminate it yourself.
So if I can put a plug in for the SWCD, we have some cover crops available for small packages. Most of them, they're different ones we have, but most of them will have a cereal rye in it for an overwintering grain, a brassica, the turnip or radish, and a clover for a legume. You get three different actions there that are all great start for yours. If you want a winter kills, you can do the radish and oats mixes, and you'll get a winter kill, and you can plant right in them next spring. If you put oats and radish on, you'll never see anything more mellow in the springtime than after them two cover crops. So come on out to the SWCD. Joelle is on here. She can put our number up, and you're welcome to give us a call at any time, or James, the extension agents, can certainly answer everything too. Any other questions? The Master Gardeners are an interesting group. Can you give us a quick overview of them if anybody's interested in
yeah, so our Master Gardeners are a great volunteer group. So they basically, to be a Master Gardener, you take a course to to kind of teach you things like, again, working with soils, how to really grow plants. And then from there, we basically, to continue being a master gardener, you do volunteer work. We've got wonderful gardens here at the office, but you can also do other work out in the community. We've got groups that work at with Fort Wayne parks. We've got groups that basically just work to provide education and teach people in the community about proper gardening, how to take care of things, and they work out of the office. We've got maybe about 200 or so active master gardeners right now, so we've got a pretty good group that's always out there learning, improving, and sharing their knowledge.
Just a thought come to me that say you can't get a deep rooting plant in your garden if it's an urban soil, so that carrot might not want to go deep. Maybe you change the variety to a stubby little plant or a less shallow one, maybe a tomato that doesn't mind container grown, I would guess grows on shorter soil, something like that. Any comments that way?
Yeah, sometimes it's all about finding what variety works really well in your setting. There's like, man, this is like Terry's topic. Is our horticulture and urban ag educator is carrots, but there's dozens of varieties of carrots, and you can find what works best for you. You can finding the variety that works best is really the key. And yeah, we've found even this last year at the farm, we get lots of donations. We've discovered that there are varieties of tomatoes that grow better in containers than others. Some of them just struggle a little bit. So you may not get the variety that you've always loved to grow, but there's going to be something that grows that's just as good, that has just as good a quality. So you just kind of match what your production goals are with what you're growing in, and find what works best in that combination.
We have a question here. How long does it take to repair compacted soil if we have tilled for years and we now grow cover crops for the past couple of years? We are going towards a no-till garden.
I really think that, again, that depends on your soil. It depends on what you've been doing. So you may be at a point where you've got good tilth. If you've been tilling, you might not be too compacted because you're always kind of breaking that compaction up. But at the same time, you've also only been breaking up the soil as deep as that tiller will go. So you're not solving the compaction layer a foot down. You're solving the compaction layer maybe 8 inches down. So some of that still takes some time to work, but chances are you're to a point that if you're using cover crops, if you're using the right crops, you should see minimal compaction issues moving forward. It's kind of my thought on that. Unless you're really walking over an area a lot or moving equipment over an area a lot, you probably shouldn't have too much of a compaction issue after a few years.
On my farm, I find that the greatest resource is dig a soil pit. Even if it's just a spade, a couple spades deep, or the backhoe we normally use, and get down 5 foot. And get in there and feel it and smell it and break it apart, and you can find out where you're at. I'm still working on compacted layers formed 20 years ago, so especially in wet spots. So it's a process. It's a goal.
And I would say, don't confuse hard soil for compacted soil. Some of our soils, they're a heavy clay base, and if it's dry, it's gonna seem like it's compacted, because that's what clay does. It gets really hard when it's dry. So it's not necessarily compacted. It's just hard to get a shovel in. So again, the more in that case, again, the more you can get organic matter in that, the more it's going to loosen up that soil. So using cover crops would be again a benefit to a clay type soil.
One of the best ways to see in compacted layers is to have radishes out there, oilseed radishes growing, because they will bore down and take a 90-degree turn and then hit a soft spot again and then go down. And it's visual to see where they're at. So, can we take a couple minutes, and Joelle, if you'd come on and talk about the urban and small farm program that the SWCD has, maybe we can cover that.
Yes, James, thanks so much for coming on today. You did an awesome job. You made a couple of jokes and you couldn't hear me, but I was laughing. So they were appreciated. Yes, so the Allen County Soil and Water Conservation District has a urban and small farms program that we're able to provide to growers within the Western Lake Erie Basin watershed. And if you don't know if you're in that watershed, go ahead and give us a call and we'll help you figure out whether you are. And again, our phone number is in the chat. So what we can offer to you is technical assistance. If you have questions based off of your garden or maybe your small farm, how to stop erosion, how to get a soil test, how to help with nutrients and cover crops, give us a call. If we don't know the answers, we will find someone who does. So that's one way we can help. We are also offering free soil testing to those in this watershed as well. So we have partnered with Extension, especially James, to do some soil testing for those in the community. And even if you are not in the watershed, you can get soil testing through Purdue Extension. It's not free, but it's not too great of a cost. So we do soil testing. And again, the coffee and webinar is a huge way that you can keep learning about different soil health practices. And so keep an eye on our website for different ways that you can learn through this program.
Joelle, can we say that we will help anybody in the area, whether it's in the county or not, or in the watershed? There might just be more resources available that we can do if they're in a certain watershed right now.
Right. And of course, if you call, we cover all of Allen County. So, or at least the district covers all of Allen. So if you call with questions, we would love to help you, whether you're in the district or whether you're in the watershed or not. But specific things like soil testing and maybe a site visit, we may not be able to do, but we also have partners that could do a site visit even if you're not in the watershed.
Great. So let's talk about some of the upcoming things. In March 15th, we have coffee and cover crop termination. Kevin Allison from the Marion Soil Water Conservation District. So that'll be an interesting one. Kevin is a great resource and a great speaker. So please join us again at 9 o'clock on March 15th. In April, we're going to have James back and he's going to talk about interpreting soil tests. So that's also a good step in what we have to learn. Once we get that soil test, we have to see what it means. There's a lot of information on there. There's a lot of ways to look at it. So I especially want to thank James today for a great program. If anybody has questions for him, call the extension office, because not just him, but there's a whole load of helpers over there. So they're always good to use as a resource. So we're getting close to 10 o'clock. I think we'll finish it up. If there's James put his email on there, great way to do it. So, and if anyone has more questions on cover crops and no-till, that is my thing on the farm here. So I always offer my ticket for the farm tours, just to call to me, call up to the SWCD. And if you want to see what I'm doing, what I've done over the past 20 years, 25 years, it's an amazing process. And I am just starting. So there's never an ending. So thank you, everybody. Thanks for joining today. We'll see you in March.